Hi, everyone. Let's start. Hi, my name is Csongor Vogel. Before I'm going to the introduction, I would like to thank you for your joining today, and I truly appreciate your decision to spending the last minutes in this amazing event in my talk. In return, I would like to bring some joy with the joy of functional programming in that. So let's get started. As I mentioned, my name is Csongor Vogel. I'm a Flutter developer based on Dubai. I'm working for Talabat, which is one of the largest food delivery application in the Middle East. In parallel with that, I'm also teaching Flutter in my home country. With my two friends, we created the first ever Flutter class, university class in Hungary. To back to the community, I'm also one of the co-organizers in the Flutter Abu Dhabi and Dubai. But let's get started with the topic why we are here today, functional programming. Functional programming is a universal topic, but today we will have chance only to look up and basically focusing on the basics and the main principles. And later on, we will connect it with the latest Dart features, which are providing the functional style implementations. And last but not least, we will also recap some useful packages which can help us. So functional programming is a programming paradigm based on the mathematical functions. It has different main goals like purity, immutability, high-order functions, and the declarative programming style. To understand them more, let me invite everyone for time travel. Let's go back to the school, and let's go back and recap what we learned about mathematical functions. As we learned in the old days, mathematical functions represent a set of rules between two sets, the set of inputs and set of outputs. If you are taking an example of a basic function, which is like calculating the double the input values, then we will see that we can notice that every input, thanks to our function, will have only one output. If you are taking another example, for example, a function which is calculating the square values for our input set, the formula is the same. Every input still requires one output. But what happens if suddenly one of the inputs is providing different outputs using our functions? In that time, we cannot call it as mathematical functions. This is the rule and principle which is named purity. Purity specifies that pure functions always produce the same output for the same input and without causing any side effects. To understand it more, I would like to start an implementation and showing another example. With a super complex formula, let's recap together what is the formula of the area of a circle. So E equals pi r squared. Let's see the implementation of it Dart. There is no any magic. We are providing one double radius value as a parameter, and we are returning with the multiplication of the mentioned parts. And we can also providing different inputs, and we can also iterating it, and we can print it to our console. But there is only one critical issue. Based on the current implementation, there is a chance that suddenly an isolates or a dangerous colleagues can somehow accidentally override the pi variable where we are definitely we are depending on it. In that time, we cannot talk about pure functions because in the console we can see right now different outputs. So basically, we failed the main principle. What can we do? How can we ensure that our function is only based on the parameters what we provided? The mathematicians solved it by introducing another principle, which is the principle of immutability. According to immutability, the data cannot be changed once it's created, reducing the chance of unexpected mutations and making our code more predictable. This is exactly what we needed in our case. So going back to our example, what we can do is for example, we can use the commonly used final or const keywords, and we can make constants, our pi variable. And after that, thanks to it, if we are running our operations in the same input fields, we will receive always the same outputs. So we could extremely independent us from other dependencies, which made our code more easy to test. Because if we want to test our function, the only thing what we need to consider is like checking the parameters of it. Okay. The second thing what we forget to do to enhance our implementations, we forget to solve the problems on the negative numbers, because as we realized that the negative numbers shouldn't provide any result in our formula. So we have several multiple options to solve it. And for example, the first idea what we can have is just checking the input parameter, what we have in our functions, and throwing an exception, an argument error, for example. But there is one issue with that. The main problem with that, by doing this, we will lose the visibility of the usage of our functions. So if someone wants to use our area of circle functions, the only thing what they can consider is that it will return with a double value. In the specification right now, there is no any description about that this function can throw an exception, and this is heavily a side effect what the users and the consumers cannot extract from the usage. What else we can do in that time? The second options, what we can consider is that, for example, introducing the null ability in our implementation and returning with null. But let's take aside a bit the error handling, and let's focus on later on that. The other idea, what we can consider it, that taking the implementation what we have and trying the right place when we can inject and insert a basic check. So in our implementation, we have a list of input fields. We have a for cycle, a for loop. In the loop, we are incrementing and reading the values. We are checking the radius. In the end, after the calculation, we are also printing it to the console. So basically, we had to understand the whole implementations what we had and to find the right place to just checking a really basic like a value check. The reason why we had to do this or recap this is not the complexity of my implementation. Basically, it was thanks to the imperative style, what was like displayed right now. During this imperative style, what we learned from the objective-oriented paradigm, basically, we had to specify step by step what kind of instructions what we want to introduce on specifying how to modify our data. The opposite of that, what functional programming really relies on is the declarative style. According to the declarative style, here we need to specify what to do with our data. So if you are taking a closer look on this implementation, then we can see that by using this style, we can have so many benefits. For example, we can have, for example, a readable code. We can easier to extend. For example, we can skip the first item. We can also change the orders of these operations, because during these steps, we are always handling immutable data, and we can be sure that we are not overriding any previously used input sets. And later on, we can take only 2 items, and we can see the print in our console. We can still consider other options to improve our implementation, or just playing with the language features what we can use. For example, we can consider something to pass a function into another function. So for example, we can save time to not looping again in our inputs fields and printing our items into the console by just passing the print function to another function. But can we do this if you are checking our original implementations? The good news that in functional programming, we can use higher order functions. Higher order functions specify that the functions can be passed as an argument to another function, and it can be also returned by another function. Why can we do this? Because in Dart language, every type, every function is also an object in a pure object-oriented languages, and we can use the function type. So going back to our implementation, if we want to extend the parameter list of our area of circle implementations, then we can easily do that by just passing it. So let's recap what we learned about the main core principles. So as we mentioned, it's heavily based on the mathematical functions. And it also representing a contrast what we used to from the object-oriented programming. Because like if you are considering the object programming, we are doing the opposite of what we listed previously. We are mutating the inner state of our objects, and we are heavily relying on imperative programming style. So the main goals: purity, immutability, the higher order functions, and the declarative programming style. These principles are purely could support by pure functional programming languages, for example, like Haskell or F#. But what about the modern languages? The good news that the modern languages also supporting a rich set of language features. But the main question that what about our beloved Dart language? Let me invite everyone for the next section, where we can discuss that what kind of language features are supported by the Dart framework. So let's get started with the easiest ones. So we can use different keywords, final const, to like specifying different constants and restricting the reinitialization in the terms of immutability. What about the list and the collections? The sad news is that even if you are using final keyword, unfortunately, the only thing what we can restrict is the reinitialization of these collections. Unfortunately, the content will be still customizable. We can add items and we can also remove it. So the immutability in collections right now not available as default. What about the classes? There is no built-in solution to mark a whole class as immutable, and please don't mix it with the latest introduced final and other class modifiers. But the good thing that we can still doing these restrictions by just specifying the properties and the fields of a class as final. And if you want to later on change an object, then we can do it by introducing, manually implementing a copy with function, and we can, for example, update this object, what you can see. What about the top-level functions? The good news that previously every example is what I showcased it was always used top-level functions, and the benefit of them is that we can create functions without any classes. We can purely using it outside of our main functions as well. A subtype of the higher order functions, we need to talk about the nameless anonymous functions. So for example, as you see in this example, we can also assign a function to a variable and we can use it, pass it later on. This can help us and gives us more ability to chain and then connect our operations. What about the closures? Closure is also a subtype of anonymous functions. Here we can see an example as a closure where basically we can have an access a variable from the inner scope. So if we are creating this myCounter closure, then calling the function multiple times, we can increment the inner start variable. Going forward, we can also use extensions. Extension also give us ability to extend an already existing object with an extra behavior, and it can also help us if we are focusing on the composability aspect of our implementations. These are the features which were already existing for a long time, but the good news that in that year there was a huge announcement when the latest Dart version provided so many language features which were long awaited. Here we need to talk about records and patterns, but before we are doing really deeply, I need to highlight that there was an amazing talk by Pascal Wesch in the same room, as I remember, where we discovered together the main usages of these language features. But to understand the syntax for the later implementations, let's do just a small recap. So records. Records, mainly we can bundle multiple objects inside of a parenthesis and we can pass them into a single object. As you can see on the right side, on the top one, we are creating a current year with two named parameters. One of them is a string, one of them is an integer, and when we are creating a next year variable and passing these records, we can, instead of overriding them, we can, by incrementing the second variable of it, we can create a new instance. The good thing that records are purely immutable objects, and this aspect of them will heavily help us in the future. What about another example? Here we can see that not just name parameters can be passed and stored in these records. We can also use like optional, not optional, like unnamed parameters as well. Another example, which like basically based on the one of the mainly longer weighted feature, which is the multiple return values. Thanks to that, from this function, from this get name function, we can return multiple variables in the same time. So if, for example, we want to print it, and we can easily take these partial objects from this bundle separately. And thanks to the usage of the patterns, which was also came in the latest features, we can also use the pattern matching exceptions to like destructuring these records on the left side. And just a fun fact that in Hungary, for example, we are differentiating and changing, swapping the orders of the names. So it's a heavily beneficial for this feature as well. Talking about more details in the patterns can help us like specifying a specific formula and checking like a behavior of a patterns. So for example, if you want to differentiate and analyzing two booleans, then we need to always collecting all of the usage scenarios what we can expect based on this pattern. For example, if you want to comment the last option and the last case, then the exhaustiveness feature will help us to detect these issues in compile time. One of the benefit of them that using pattern matching in functional programming that we will always ensure and force our colleagues as well to like handling the cases and the return types of our implementations. Thanks to the object destructuring and the switch cases, we can use another aspect of the pattern matching, which is the usage of the algorithmic data types. So here, if we want to handle like a type of family-related types, for example, in this case, we can create using also the latest class modifiers. We can create CR classes with the name of the shape, and we can based on the type, we can run different operations inside of a switch case. So basically, we learned and we summarized all of the tools and use cases what we can use for functional programming. So now, as we are familiar with them, let's go back our previous example and let's try to like enhance it. So the array of the circle was the previous one, and something what we can expect in food delivery applications is like handling the array of a delivery. So this is the next task what we receive in our sprint, that we need to case and we need to handle a get area function, which will provide an information about the area of our delivery. The first thing what we can see is that if we return an area model in an optimistic way, and if we want to heavily rely on that, this is the only thing what we are expecting from this function in the beginning. But in the real world, if we are going one layer below, then we can see that like so many exceptions can be also like expected by using these functions. We can have different server issues. If the user is not connected to the internet, we can receive authentication or parsing problem. If our from JSON or the from map function returns in an exception, and we can have also different type errors. So the basic issue from the beginning was what we also discovered previously when we wanted to throw an exception, that unfortunately in Dart we cannot, in the signature, we cannot determine that this function can throw an exception or not. So what we can do, before we are going into it, let's recap also like how does it look like the consumer side. We can see the main function, even if the previous part was like handling and checking different exceptions, we still need to wrap from the usage side if the lower layers didn't handle them properly. One thing what we can do is like based on the patterns and other latest Dart features, it's like creating an own result object. We can specify it as a sealed class, and we can have two subclasses. We can also restrict the implementation and the inheritance of it by introducing and mark them as final classes. And we can differentiate the success and the failure part. If we want to extend it, we can do it by just this step. So going back to our example, instead of just rethrowing exception from the different branches, we can update the signature of our function, and instead of an error model, we can specify that this function can also return based on the success case an error model, or in a failure case with an exception. If we are also like matching this scenario, the introducing of this type in the consumer side, then in our main function, then we can also using the latest pattern matching and the exhaustiveness in our switch case to like listening to the success and the failure case. Now we are more, how should I say that, we can be more confident about the usage of this function, because we can see and other colleagues can also expect from the return types that what are the expected behaviors. In the next sprint, our manager came with another idea, like after we have an information about an area ID, we should also displaying the users, the best deals or the best available deals based on different restaurants. So according to the specification, we need to handle another two functions. And we really likely accepted the 1 week sprint goal as well, because like we learned the usage of the results, so why shouldn't we introduce it and handling these scenarios with the same patterns? But now the issue, the following issue happened, that like introducing the results in every cases, just calling 3 asynchronous functions sequentially can end in this scenario, with what I couldn't like call it as a readable solution. By the way, this problem was also like rightly pointed out by Andrea Bizzotto in this article. So what else we can use further? Let's recap what kind of available packages there are in our beloved hosted packages. So from the useful packages side, we can always consider the usage of the darts and the FP Dart packages. And if we want to just specifically focusing on the immutability part, then we can also use different packages which are focusing on the issue what we faced with the collections. And also we have the equatable and the freeze packages, what we can also use by creating immutable data classes. By the way, the freeze also provided something similar approaches for the CL classes when the latest Dart features was not available. But the good thing that for the teams and the organizations who couldn't update to the latest Dart feature, they can still use these packages if they want to still support multiple return values or seal unions and other options. In my session, I would like to highlight the FP Dart package cases. FP Dart is a newly introduced functional programming package, which is like well documented. I just showcased a small part of the entire base of the documentations. It also providing a wide variety of extensions and the main types that we can use to it from the functional programming. From this list, I would like to highlight, first of all, the aider function. The aider functions, similar to the result, differentiates 2 subtypes. One of them is the left side, and the other one is the right one. Most of the times, we are injecting and placing the failure specific values to the left, and we are using the right side as the success case. It has also like a try-catch constructor, which can help us to like connecting these type with the future API, and we can use different map functions and extensions to like chaining these types with other ones. And of course, for destructuring the results from an aider type, we can also use the pattern matching. Going back to our previous result, let's try to recap like how our implementations look like by using the result API. And if we want to change it from and adopting the latest either one, then we can do it. We just need to update on the top side the signature of our function, and instead of passing it in a failure and the success case, we need to differentiate the right and the left side. Similarly to the consumer side, instead of using the result one, by introducing the either, we can also still enjoying the pattern matching pattern in our implementations. Now we can also consider another aspect or like a further enhancement in our implementations. If we are taking a look that our either type is still wrapped by the future API. Unfortunately, the future API is not something what we can heavily chain with other functions and other types in our implementations in a functional style approach. So the good thing that the fpdar package is also providing another type, which is super helpful in our case, which is the task one. The task basically is a wrapper around the future. We can use the lazy evaluation aspect of it. So for example, on the right side, you will see we have a run function. So when we are creating a task, it won't be created, initialized, and executed in the same time. We need to do it later on by using the run function. And it has also like several extensions what we can using for compositing these functions and chaining them, for example, with the either and others. And there is another good thing that we can also access different utility types. So for example, the task either can merge the good part of the task. That means that we can use it on asynchronous functions, and we can still handling different cases, error cases. So looking into this implementation of the task either, we can see that we can reuse the try-catch constructor of this task either type. We can return the first time with the result part of it, and then on the bottom side, we can just directly passing the values as a string to the left side. Going back to the previous implementation, still in our main function, we just called the get area inside of a future one. And if we are migrating to the task either, then we can see that first of all, we are always creating a task, which is the outside layers of our type. And by calling the run function that, we can have an access on the either itself. After that, we can still reuse the pattern matching what we get used to it. Going back to our main problem and our main blockers what we faced previously by using the results, adopting the task either, on this case, we are able to like reducing the implementation to this side. As we see that we received a much more readable implementation of itself. Let's go into the conclusion part of it. To summarize what we learned previously, the main thing that we always need to like understanding the main concepts of functional programming and applying it on our daily basics. The good thing about functional programming that like focusing on immutability or purity, it will still help us our daily works. We will adopt and receive a much more testable code. And by focusing onto the immutability side, we can also be sure that we can avoid more mutations and side effects. Next thing what I would like to highlight is that if we are also like aware about the latest Dart features, the patterns and the records are still like a newly introduced types. So we are still in the learning phases and like adopting and providing the best practices in the community. The next thing what I will highlight is that start small. As I mentioned previously, let's focus on one aspect from the previously mentioned main goals of functional programming, and let's adopt it and adopting the ideas step by step. Let's try to adopt it together with our colleagues. For example, if you want to refactor the network layers by introducing a result class or a header type, we will automatically force our colleagues as well to like adopting and following these patterns. So always let's try to get together and discussing and learning together the usage of functional programming. We can be functional anytime tomorrow, but we don't need to be functional 100%. There are still cases when the object-oriented programming can still be beneficial by mutating different state. For the functional programming, I also added some references as a part of this slide, and there is also a playground which is available in this GitHub repository. Thank you for coming, everyone. And even if it's in the late hours, I will be also being around here. But let me know if you have any questions. Thank you so much.